Okay, I'm trying something new, trying to put my face in there. I don't know if that's a wonderful thing or a bad thing. Um, I'm glad to see y'all again. I really missed you. And as you can see, my printer is not doing a great job with colors. Your notes will be fine though. Today, we're going to look at logical statements, simple and compound statements, quantified statements, and symbolic notation. So in general, you can have factual statements, commands, opinions, questions, and exclamations. Those are all statements in the real world. So a factual statement might be, you must pass the bar in order to practice law. A command might be, enjoy math. An opinion might be, math is the best subject ever. Because this isn't true or false. It just depends on the person saying it. A question might be, how are you doing? An exclamation, oh my goodness. So in logic, and that's what we're worrying about right now or caring about, a statement is only going to be a sentence that can be objectively determined to be either true or false, but not both. So let's look at the following sentences and see if any of them are logical statements. Many scientists work in laboratories. This should be a period. Is this either true or false, but not both? And can it be objectively determined to be that? Well, is it true? Is it true that many scientists work in laboratories? And can we determine that objectively? That means that every single person would have the same answer. Well, yeah, that is true. It doesn't say all scientists work in laboratories or that no scientists work in laboratories, but just that some of them do. So this would be that it would be true, and this is yes, a statement. And when we use the word statement, we mean logical, in logic. Is that your laptop? No, this is a question. Questions are not statements. So no. Ouch, that hurts. Okay. Exclamations are not statements in logic. 8 divided by 2 plus 432 equals 436. Let's see. Okay. 8 divided by 2. Order of operations tells me that I divide first and then add. So I have 8 divided by 2 plus 432. 8 divided by 2 is 4, plus 432, that's 436. Okay, so this is a statement and it's true. Now we've got 8 divided by 13 plus 432 equals the square root of 39. Well, if D was a statement, then E has to be a statement. Is it true or false? We've got 8 divided by 13 plus 432. We have to get a common denominator. Let's see, 432 times 13. 2 times 3 is 6. 3 times 3 is 9. 4 times 3 is 12. 1 times 2 is 2. 1 times 3 is 3. 1 times 4 is 4. Then we add 6, 11, 6, 5. So on the left-hand side, we get 5,613, pardon me, 5,616 divided by 13. Is that equal to the square root of 39? Well, actually, no, it can't be, but let's prove it mathematically. Let's assume that E is true. Then we would have 5,616 divided by 13 would equal the square root of 39. Oh, I never added. I've got 8 over 13 plus 5,616 over 13. Thank you. Thanks, you guys. 6 and 8, that's 14. So we get 5,624 over 13. And I'm just going to cut to the chase so that it's not so horrible for y'all. Where's my calculator? Here it is. So let's just see. 39 square root is approximately 6.2. So we want to see, we know that the square root of 39 is about 6.2. What is 5,624 divided by 13? Is that also about 6.2? 5,624, is that right? Yes, divided by 13. Oh, way different. This side is approximately 432.6. Okay, so let me see what the computer is saying. Okay, so statement E, it is a statement, but it is false. Okay, let's look at statement F. Her book is about database management. Well, this can either be true or false. No matter who reads it, it can be either true or false. So this is a statement. I don't know whether it's true or false, but I know it's one or the other. Watching too many videos makes you tired. That's an opinion. So some people would say that's true. Some people would say that's false. Anytime something could be true or false, that's not a statement. So the only logical statements in this set are A, D, E, and F. Well, now let's look at simple and compound statements. A simple statement is just like it says, one statement. A compound statement is made up of two statements joined by a connective, where connectives are and, or, if, then, if, and only if. And is called a conjunction, or is called a disjunction. If, then is called conditional. If and only if is called biconditional. Please make notes of this and write it down. You do not have to memorize it. Just have it handy. So let's look. We want to determine if the following statements are compound or simple. And if they're compound, which connective is being used? So these are all going to be statements. Our school mascot is an armadillo. Are there two ideas in there or just one? Exactly. So this is simple. Padre Island and Big Bend are in Texas. Oh, okay. There are two ideas in there. They're combined, but Padre Island is in Texas and Big Bend is in Texas. So this is compound. Let's see which connection, which word is in here. And is in there, and is called conjunction. So I'm going to write this down. We have a conjunction because we have a compound statement, and compound statements are of the form and, or, if then, if and only if. If you register for Wi-Fi service, you will get 1 free week of access. You will get 1 week of free access. If then, even though they don't put the word then, if something, then consequence. So this is also compound. It's an if then. And if then is called conditional. So let's write them down here. A was simple. B was compound conjunction because of the word and. C was compound conditional because of the if then structure. Let's see what D is. Tomorrow is the last day to register for classes. There's just one thought in there. There's just one thing. So that is simple. And let's look at the last one. In the interest of saving the planet, I plan to buy either an electric car or a motorcycle. So this whole intro, it's important, but to the world, it's important, but for logic, it's just extra. So here is the actual statement. I plan to buy either an electric car or a motorcycle. So we have 2 things going on connected with the word or. So this is compound, and or is called disjunction. Great. Now we're just going to take statements and parse them up and make them really, really crazy. Quantified statements. A quantified statement includes a term such as all, each, every, no, none, some, there exists at least one, something like that. These are called universal quantifiers, the all, each, every, no, or none, because they either include or exclude some element of some set. The some, there exists, or at least one, are called existential quantifiers because they claim the existence of something, but they don't include the entire set. So, oh, and one more thing, a negation is the logical opposite of a statement. Okay. So we have universal quantifiers, all, each, every, no, none, and we have existential quantifiers. And those are words like at least one, some, there exists, because these terms say something is going to work, but they don't say anything about the whole clump. Whereas these terms, all, each, every, no, and none, they make a statement about the entire group. All ships go to China or Japan or something. That's making a statement about all ships. Every March, we have to get ready for taxes. That makes a statement about every single March. So let's look at some examples. Oh, first we're going to look at negating each of the following statements using where these statements have quantifiers. And it helps us to know which clump the quantifier falls into. Some people are Dallas Cowboy fans. Some is an existential quantifier. To make it false, we're going to say that what's the opposite of some people? We could either say, no people or Dallas Cowboy fans. Is that the opposite of some? Because there's no people, that's the opposite of all people. So for us, for our class, this is actually going to have to be the way we do it. There is at least one professor who does not have black eyes. So at least one, we would say none. There are no professors who do not have black eyes. No nursing student is also majoring in criminal justice. So we could say some nursing students are majoring in criminal justice. And finally, every student who does not do homework will not pass. So we could say no student, we could negate this statement a couple of ways. We could say no student who does not do homework will not pass. But that has so many negatives in it that we can make it simpler. We can say every student who does homework will not pass, which is a silly statement, but that's the negation. Every student who does, so the opposite of does not is does, will not pass. Crazy, man. Okay, finally, let's look at symbols. Because of course, this is math, and we like to make something simple into something a little bit more complex. If we have this statement, Juliana works hard on math, so she passes her math tests. Do you see that this is like an if-then? If Juliana works hard in math, then she passes her math test. This is in the if-then structure. We're going to let P B, Juliana works hard in math. We're going to let she passes her math test be Q, and the structure will be if P, then Q. But we write if P, then Q in this way. If P, then Q. P with an arrow to Q means if then. That's the conditional. So we're going to let P, Q, and R stand for statements. The word and is this upside down kind of arrow thing. Or is a right side up arrow. If then is an arrow pointing to the right. If and only if is a double-edged arrow. Not is a tilde. This is the tilde. Just a little squiggle. Okay, so let's look at this. If P is the dog weighs over 100 pounds and Q is the cat is named Linus, write the statements for each of these symbols. Okay. So let's write P stands for the dog weighs over 100 pounds. Let's let Q be the statement. The cat is named Linus. And let's see what these things mean. A is tilde P and then an upward pointing Q. Tilde P means not P. Q is just Q. This symbol in the middle is or. So we have not P or Q. So what does it mean to, how can we write the opposite of the dog weighs over 100 pounds? Less than or equal? So the dog weighs less than or equal to 100 pounds, or the word or the cat is named Linus. Wow, okay. Let's look at B. We have a tilde and then parentheses, P, and then this symbol, Q. The symbol looks like a tent. So we've got tilde means not. And we've got P. This tent thing is the word and. So first let's write what P and Q is, and then we're going to negate it. The dog weighs over 100 pounds and the cat is named Linus. That's P and Q. Well, what does it mean to negate it? Both things have to be true in order for this and thing to be true. So to negate an and argument, only one of the inside things needs to be false, then the whole thing is false. So we get the dog weighs less. I'm just going to put less than because we already looked at the or equal. So less than 100 pounds. What does it mean to negate this? If either thing is false, then the whole thing is false. Oh, okay. So the dog weighs less than 100 pounds, or the cat is not named Linus. And that's what it means for one or the other to be false. So the cat is not named Linus, or the dog weighs less than 100 pounds. Great. Now we just need to do C, and let's see, I'm going to put it on the back. Part C is Q. We read this, Q implies P. Q implies P. And you write this using the words if, then. You don't have to use those words, but it certainly makes things easier. Statement Q was the cat is named Linus. Statement P is the dog weighs over 100 pounds. So we're going to write if the cat is named Linus, then the dog weighs over 100 pounds. Awesome. Let's start with statements and use letters. So we're going to, we're going to let P represent today is sunny, and Q represent we are going to the beach. Okay, A, we are not going to the beach. We are going to the beach, we are not going. Okay, so this is not Q. Tilde Q. It is sunny and we are going to the beach. It is sunny, we are going to the beach. Oh, okay, this is P and, which one was and? The tent. P and Q. Because it is sunny, we are going to the beach. Ah, these are different words, but this is an if then. If it's sunny, we're going to the beach. Okay, so the sunny comes first. P implies Q. What about D? If it is not sunny, we are not going to the beach. So it's still if then, but it's the negation of P and the negation of Q. So it's going to be tilde P implies tilde Q. If if then, if it is not sunny, then we are not going to the beach. We are going to the beach if and only if it is sunny. That's a little contrived, but so we're going to the beach. It is sunny. Q, P. So we've got Q and P. If and only if. If and only if is a double arrow. And this is exactly why mathematics uses symbols, because it takes much less time to write down this. Okay, Let's go the other way again. Let's let P represent my cat is under 8 pounds, and Q represent that dog has hair longer than 2 inches or more than 2 inches long. That's a long-haired dog. What is not P? I'm going to get this extra sheet. Not P. My cat is under 8 pounds. I could write, my cat is not under 8 pounds. I could also write, my cat is over, is 8 pounds or more. P and Q. Remember, the tent is and the right side up one is or. P and Q. My cat is under 8 pounds. And that dog has hair, long hair. I'm just going to put that dog has long hair. I didn't write that dog has long hair on here because long hair is subjective. Some people would say 2 inches is long. Some people would say 2 inches is medium. Some people would say it's short. So the dog has long hair isn't a good statement, but the dog has hair more than 2 inches long. That is a good statement. That's objective. But I'm tired. Okay, so C. Tilde P implies, tilde Q implies P. So not P. The dog doesn't have hair more than 2 inches long. So it's if then, if the dog doesn't have hair more than 2 inches long, then P. Then my cat is under 8 pounds. Okay, what about D? Q, if and only if P. That dog has hair more than 2 inches long, if and only if my cat is under 8 pounds. Finally, E is P with a right side up tent, kind of, Q, and that symbol is or, P or Q. So we would write, P is, my cat is under 8 pounds. My cat is under 8 pounds, or that dog has hair more than 2 inches long. Okay, that's the end of this section. Oh, this is section 3.1. Okay, great. I'll see you in a few minutes.